Okay. Thank you all for coming to this presentation. As the title says, I'm going to talk about the Docker Container Executor. Um, my name is Abin Shahab. I work for a company called Altiscale. It's a small startup. And Altiscale provides Hadoop over the cloud. So that's where kind of our relationship with Hadoop and Docker come in. I work a lot on Docker. I contribute to Docker, and I have also contributed to LXC, which is the underlying driver that we use for Docker, the native driver that launches Linux containers and Linux namespaces under Docker. And so today I'm going to talk about how in Hadoop we can launch Docker containers instead of the regular Yarn containers and launch tasks in there. So I'm going to talk about the problem that I plan to resolve or solve. So the problem is resource contention, where tasks of different jobs can take each other's resources. By the way, let me know if you cannot hear me properly. So the specific problem that I'm going to talk about is software dependency problem. So if you have two tasks that have different software dependencies, say for example, you're running Ruby streaming jobs and they require different Ruby gems, then you will run into a problem of, you may run into a problem of having to provide these dependency gems in your node manager machines. And that becomes a big problem for the cluster maintainer. So Docker plans to resolve this, and I'll show you how. And then I'm going to go into talking about Hadoop and Docker. What do we plan to do in future? So let me start.
Is your presentation going to be available?
That I think so. I mean, so I have an online version of it already, and I'm going to try my best to make it available. Absolutely, yes. So in the movie Despicable Me, there's this evil scientist called Gru, and he has minions. So he gives them tasks, simple tasks like go make some eggs, clean the kitchen, get me some bananas. And the minions run around and do these tasks. However, minions sometimes get into fights, and they interrupt one another's tasks. So now Gru has to plan on strategies to prevent them from interrupting each other's work. So how is this related to Hadoop? Well, in Yarn, the way application masters give tasks to containers is similar to how Gru gives tasks to his little minions. And now we have to plan on strategies to stop containers from fighting with each other. So let's work on an example. So a client submits a streaming job to the resource manager. Resource manager forwards it to the application masters, and to an application master. But there could be, like in a regular cluster, you could have multiple application masters working concurrently. And as you can see here, there's two application masters, and they're doing two different jobs on the same cluster. And they are launching containers. They're launching the tasks on containers. And these tasks could easily require, say, one task can require, say, the Nokogiri gem version 1.6.6, and another task could happen to require the same gem but a different version. So now you have a dependency issue, and your node manager has to supply these two gems, and it will not be able to work. So now there is, for some cases of some software dependency issues, it is possible to resolve it with the distributed cache, which is a brilliant solution to a lot of problems, software problems in Hadoop. You can kind of provide this job-specific binary that your tasks can pull up from the cache, and they can invoke the binary. But it is a big problem to set up if your binary has native dependencies, as in the example that I gave. So Nokogiri has a native dependency on libxml. And if you don't have the correct version of libxml, you're not going to be able to run Nokogiri properly. So that's really hard to set up with distributed cache because it expects this to be available on the system. So is there really a solution to this? And the solution that I'm proposing is a new container executor alongside. So right now there's default container executor and the Linux container executor in Hadoop. So there's this new container executor, Docker container executor. It was submitted in Hadoop 2.6. It's available now as alpha, and you're welcome to check it out. So how does this actually solve the problem? So if we look back at that problem of supporting two gems that happen to be required by two tasks that are running on our system, on our machine, on this particular node manager machine, Docker containers would not install it on the file system of the machine. They would install it on individual file systems of each Docker container. And these file systems will be completely isolated from the machine and each other. So you can install whatever you want. You could have one data scientist going and installing MATLAB libraries, another data scientist going and installing R libraries, and they can have all kinds of system dependencies, and you will still be able to support them from one node manager. You wouldn't have to control that, oh, this job goes to this node manager and this job goes to that node manager. So that's the solution to this particular problem. But now let's look at this from a larger resource contention issues. So what are the resources available in a node manager machine? There's CPU and memory. There's network interfaces. There are users. And then there's the file system. So what the first container executor that we have in Hadoop is the default container executor. What that does is it's running without pretty much any barriers. So it runs as root. You can choose to run it as root. And you run without any kernel rules to prevent it from taking any CPU and memory from any other containers. So if it wants, it can take CPU and memory from other containers. Next is the Linux container executor, which is a huge improvement over this. So now there are C group rules. And these C group rules is like a hard barrier for these container to take CPU and memory from other containers. And it also runs as a deprivileged user. So it cannot do things like look at the network interfaces of the machine and turn off all the network of the machine, or any other anything else malicious. But the file system problem that I previously described still remains. So now, what Docker Container Executor does is it adds to what the what LCE provides is the individual file system, and it can optionally also provide a network namespace where it can have its own network interfaces. So now I want to go to the demo where I want to demonstrate this. So what I want to demonstrate is, so we already know that supporting two different versions of Nokogiri gem on the same node manager is not easy. But we're going to try running two different jobs on the same machine, on the same node manager. So first, I'm going to run Nokogiri, a streaming job that requires Nokogiri, particular version of Nokogiri, on a Docker container that does not have it. So this will fail. So this is to illustrate that this container is completely isolated from anything outside, and if you don't have the gem, this job fails. And then I'm going to run this in a container that actually has the gem. So this will pass. Thirdly, I'm going to go and require a different gem for my streaming job. And if I run it in that previously mentioned Docker container, which has a different version of the gem, this will not work. And lastly, I'll show that if you run the right version of the job with the right version of the Docker container, it finds the gem and it will run. And we can have these two working streaming jobs run concurrently, and they will still be able to work because the containers completely isolate the file systems.
Is configured with the Docker Container Executor as the container executor, so it launches Docker containers. And the other thing is the image that is the Docker image that is used cluster-wide. So if I don't mention an image in the job conf, then this is the Docker image that's used. Next, this is the machine that I'm going to, where I've set up the Hadoop library so that I can make calls to that cluster as a client. So the first job that I'm going to run from here is going to use, we're going to cat this cities file, and this file also exists in the HDFS, and it is going to use bin cat as the mapper, and is going to use this Ruby file as the reducer. This Ruby file doesn't do anything very interesting. It also does cat with the line number. It does require a specific version of Nokogiri, and I have configured the node managers with a different version of Nokogiri just to create a conflict. So if we look at the node managers.
Thank you. So my demo kind of started a little bit ahead. So anyways, I have a 3-node cluster here, and these are the 3 slaves of the cluster. So the slaves have a particular version of the gem installed, and what I am going to do is run this streaming Ruby job that pretty much does the same as cat, but it will require a different version of this Nokogiri gem, and it will fail. It will be running in a container that doesn't have any gems, so it will basically just not be able to find it and fail. You can start.
We can see that they have a different version, 162.rc2, and then the actual cluster has 166.1. So now I'm going to run a job that will use this file as a reducer, and that will actually fail. So as I mentioned, bin cat is the mapper, and my Ruby file is a reducer, and we started. So the mappers went through, and now the reducers are failing. Now we can look at this application in the cluster. So let's look at all the applications that are running. Let's order them by finish time finished. And let's look at the history. So now let's dig into one of the reducers, and could not find Nokogiri version. The gems. Okay, great. So that's the reason why it failed.
Pause it. Next. So yeah, as mentioned before, so I've basically shown you that I run the job and it doesn't have the gem that it requires, so it just failed. So the next thing that I'm going to show is I'm going to run this on a Docker container that has the gem. Same job on a Docker container that has the gem, and we'll be able to pass. Can you run it?
Next, we need to pass this job. So I will run this command, which will pass a special Docker image on the job conf, and it will say that use this as the image for the reducer. Let me run that, and as you can see, so here for the reducer map reduce n, use this image as the reducer's image. And now the reducers are starting. Next, we want
Can
to
you pause it?
actually run some.
So yeah, so it paused. It passed, but I mean we knew it would pass. So next is the actual. If I run this streaming job and it happens to run in an environment which has a different gem, is it actually going to use the host's environment, or is it going to be using the container's environment? So the job that I'm going to run is going to require the gem version 1.6.2, and as I showed you before, the host has the gem version 1.6.2. So say if you're running LCE, this would actually pass. But in this case, I would intentionally make it fail because I'm going to run it in a Docker container that does not have that gem. So what's the advantage of? I mean, what's the point of this demonstrating this? The point is that this is completely isolated from the host's environment. So you are running this, and it will not be able to find the host gem. This is completely its own gem list that it looks through, and it will actually tell you that I could find a different version of the gem, but I cannot find the version that you need. Go ahead.
Something with this image, but we want to so I have a different cat file which is equally innovative. It's does everything same as before, but it requires a different version of Nokogiri. So this is the Nokogiri gem that was actually available. That is actually available in the cluster. So now I want to demonstrate that I will run this cat and it will actually fail because the Docker container only has a different version of gem, and it will be shielded from the clusters, what the node managers provide. So now the difference between what was being run before and now is that it is using my second gem, the Ruby file, as a reducer. So now mappers are going through, and now reducers have been starting. Let's try to find this application. Applications. Okay, so it's finished, it failed. History. So now you are actually, it actually spells out, I couldn't find this Nokogiri. I did find another Nokogiri, but really can't do anything with it.
Can you pause it? So my next example is basically I will run this streaming job in the Docker container environment that actually has the correct gem, and it will be able to pass. So by then I've demonstrated that we have two streaming jobs with two different versions of gems, and they will require two different versions of Docker containers. And we will actually, after that, my last example, I will show that they can run also concurrently on the same cluster, and they'll be just fine. Go ahead.
So, job not successful. So how to make this job successful? So luckily I have an image. So the only thing I'm going to change is I'm going to run this with this other image. So now, as you can see, for all of the cases, it's using this image. And now it will actually succeed. So now reducers started, and there, succeeded. We can actually run both jobs simultaneously. So here I'm logged in as a different user, and I'm going to run that. I'm going to start that job that I showed you. 1 and 2. So this will now pass because it really doesn't matter that these jobs are running concurrently. They will both use the images that they were specified, and they will be able to pass. So reducer is done. Reducer is done. And that's my demo.
So one thing I didn't mention before is by Docker image, for those of you who are not familiar with Docker. So Docker provides this capability of kind of freezing your operating system into this kind of tarball-ish structure called image, which gives you the entire operating system environment with some differences. But say, for example, you get your own file system where you can have your own gems. And so in this example, what I was doing is I was running 2 different streaming jobs with pointing at 2 different images. So they could have their own gems, and they will be able to run. And the additional advantage you have is you as a developer can try this out on your development environment. Then you send your image to production, and it is guaranteed to run exactly the same way. So that's a huge advantage of using Docker. So now I want to talk about what's coming up future for the Docker Container Executor. So one of the things that we would really like to do is kind of give users a way to kind of port between the Linux Container Executor and the Docker Container Executor. The Docker Container Executor internally uses the Linux Container Executor binary. This is the patch that I submitted. It's not on the Hadoop 2.6 yet, but it uses the same binary and kind of uses the same method calls that the container executor.c binary uses to do create the directories, localize, things like that. So porting between them is actually not hard, where a user at the job conf will be able to say, okay, I want to run this job in an LCE mode versus a DCE mode. In LCE mode, it will run on the node manager hosts as Linux Container Executor, and once they're comfortable with it, they can try it out on the DCE mode on the Docker Container Executor. But I mean, for this to run it in DCE mode, they'll have to also provide an image that has fully contained all the things all the dependencies that they need. So this is kind of trying to give the users everything they want. And next thing, and this is really important, is right now we provide the Docker Container Executors use the host's network, meaning the host interfaces, and so it is possible for a container to kind of take away bandwidth from other containers and kind of completely starve the other containers of network bandwidth and throughput. So we want to prevent that. So Docker containers, when you run them by default, they get their own IP addresses. And the problem arises on how do you make these containers talk to the talk to the resource manager and the name node, and also how do you make them talk to one another so that your containers of a particular job can talk to each other, but they don't need to talk to they will not be able to see other containers. So this is possible through software-defined networking. We are trying out Open vSwitch as an implementation of software-defined networking. We're experimenting with GRE tunnels to isolate traffic among the containers of different jobs, so that there's these, you can picture them as these networking bubbles where within the bubble all the containers of the particular job resides, and they cannot talk outside that bubble. Next is user namespace isolation. So LCE runs as a deprivileged user, and right now there's a patch also for DCE to do that, for Docker Container Executor to do that. And this is very important. But there are cases where the user may want to run as root on their container. They want to be as root on the container. They just don't want to be the root on the host. We don't want them to be root on the host. Unfortunately, there's only one root. And right now, by default, all the hosts users get mapped to the container. So the root on the container is root on the host. So if you become the root on the container, you are root on the host. And if you have some way to look at the host, you can start doing very disruptive things to the, say, the prox file systems or the devices. So how do you actually prevent that? You can, with user namespace mapping, you can map a deprivileged user as the root on a particular container. And that user can be this pretend root on the container and can do root-like activities on the container. It can create network interfaces on the container, and it can write to some places in the proc file systems also. And it has pretty much root-like abilities, but outside the container, it has no privileges. So, whoops, I guess I moved too far. But yeah, so that's one of the future things that we really want to get to. That's my presentation. Go ahead. Question?
Can you hear me?
Yeah.
So thanks a lot for the work. I think that looks very promising and useful. In the context of dynamic partitioning, what's your take on Yarn, Mesos, and Myriad?
So, what do you mean by dynamic partitioning?
So currently, if you have different workloads, let's say you have a Spark job and you have some Node.js applications, whatever, the best practice is to statically partition your cluster. Say, these 50 nodes go for the Spark, these 50 nodes go for Node.js, whatever. Now with Mesos, and particularly Myriad, it allows you to run Yarn under Mesos, and you can do dynamic partitioning. You can say, at 6 o'clock, I know that the main business is gone, so I'm going to dedicate some 20 more nodes to my overnight Spark job. And especially in terms of utilization, I would be interested in, did you do any research there? Did you see, I mean, the isolation bits, I get that. That's sorted here, no doubt. But in terms of overall cluster utilization, did you do any experiments there? Did you do any research?
No. So we are kind of at the beginning stages of it. So in Altiscale, part of our work is kind of creating these elastic clusters that can grow and shrink. The node managers and data nodes can grow and shrink. And for that, we do need some kind of overall scheduler that, and Myriad has possibilities. But
it's early days, no doubt.
Yeah, but we haven't looked at it. I mean, Yarn also is a possibility, but right now we are looking at Yarn as the runner for the individual tasks.
Pretty practical questions. If I want to try this construction, and I have already running jobs and so on and so forth, can I just correct client Yarn configuration without affecting server-side configuration to switch for particular job? And if I switch, how it affects performance of start-stop jobs, time to deploy and so on and so forth? Do you have some digits or
Yes.
recommendations?
Yes. So on the performance side, there is very little noticeable difference, and that is, well, one thing. I mean, the kind of the scapegoaty answer is it takes longer for the JVM to start up, but actually Linux namespaces are very well worked out and very well. I mean, they have been used for a very long time, and so Docker pretty much is a combination of several namespaces, so it does not add overhead. There is some overhead to pulling down an image if you have to, but that can be managed. That's like one time per image. So if you can kind of pre-do it, or it gets amortized over however many tasks use that image. So you pay the cost in the first task, and then you basically get amortized. So there's the kind of the performance answer. Now, can you switch right now without changing the server? No. So that's where that future patch. I think so that patch is actually up there to combine the LCE and DCE, where you will first configure your cluster on the server side as being able to support both LCE and DCE, and then on the job conf side, user can choose, okay, I want to use LCE or I want to use DCE for this job. So then at that point, there's no cluster configuration change.
What is time frame for this ability?
So the patch is up there. I mean, feel free to go and comment on it. We definitely have Altiscale has a lot of interest in it, and so we're working on it. But it's difficult to kind of put an estimate on times.
Months, years, weeks?
Not years. Yes, not years.
Sounds like a couple of months.
Yeah, that feature is not as complex as say the user namespace feature or the network isolation feature, which will require more design work. And
if my job needs to access to HDFS, that means that the container needs before start or after starting first loading all the data within the container. So this additional task will be required for every job then?
So the container, say you are running, let's first start with, say, MapReduce. So your container has the Hadoop libraries to talk to HDFS. So that's a first level assumption to run these jobs. It has Java, obviously, to run the mapper tasks or the reducer tasks, and it will start that up as the first stuff, as the first thing it does. So how you run Docker containers, you say, okay, Docker run this command, and this command is basically whatever command, say, your default container executor right now runs. And another thing that happens is the local and the log directories on the host for that container get mounted on the Docker container, so that the Docker container has access to those directories as it had with the default or the Linux container executor. So those things we have tried our best to make it interoperable with the current jobs. So you don't have to change the current jobs. Does that answer your question?
Well, yes, more or less, because I suppose that if you start a container on a node that does not contain the data, anyway, it will have to ask anyway to the name nodes where are the data, and then loading them locally in the container. So that phase should be mandatory for every container job then.
Yeah. So it will work as the same way as it is now. And moreover, right now, the network is the same. So it is basically adopting the host network. So to the outside, it looks as if the default container executor or LCE is asking for the data.
Okay, so I imagine the Docker containers have to be present on the nodes beforehand, or can you provide them dynamically?
So I think what you mean is the Docker container images. Yeah. So the image is the kind of the static tarred up version of the OS that it's going to run. And yes, so either they have to be present on the image, or as I've mentioned, what happens is when you say Docker run something, Docker pulls that image down from the registry, and this registry could be a private registry or the Docker public registry. So your first task is going to be paying for that pull, and then all your other tasks on that particular node manager will be able to use it. And the alternative to that is you have the image available in your node managers.
Okay, so is it something possible to always pull the image? Imagine my system is running on memory, for example. So I don't want to have many Docker images installed locally. So is it possible to just pull it all the time I receive a mapper that use a given?
Yeah.
Okay.
It is possible. You have to set up.
Would it be efficient? That's the question.
Depends on how you set up your Docker registry. So how you set up the caches for the registry so that all your node managers don't pound one particular registry, that they get properly distributed. But it is possible.
Thanks.
Would you quantify the overhead for running with the DCE compared to the regular container executor?
So there has been tests against VMs and Docker containers, and Docker containers startup time compared to VMs is it's orders of magnitude faster. I don't have actual numbers. It is almost close to starting an executable on the host system. So the startup time for the starting of the creating of the namespaces is minuscule. So it is far more dominated by other things that are running in these Yarn containers.
So it's really just the overhead initially to pull that Docker image onto the machine?
Yes.
Okay, great, thanks.
About port forwarding at the level of the cluster, if I want to deploy a small, let's say, web application, could be Node.js, I want to package U. Do you imagine some kind of like IP forwarding where you just, because you can know the port, but you definitely don't know the host where this will be deployed?
Yeah.
So do you imagine something where we could, for example, contact the resource manager and say, okay, on the port 10,001, and forward it to the Docker container that, you see what I'm speaking? Yeah,
so I can talk about it in terms of individual applications outside Yarn.
Yeah,
so
outside.
there is very good mechanisms and examples in Docker on port forwarding. You can start up a MySQL server on a machine on a container, and you can say that this is forwarded to the port, say the port 80 of the MySQL server is forwarded to the port 8080 of the host, and then you can just say on the host's 8080 talk to the MySQL server.
Shouldn't be Yarn to manage this in the case of Hadoop?
So we are still working on that part. So I have tried with port forwarding, haven't had much success, which is why we kind of dropped down to use everything from the host, where the node manager appears as if it's coming from the container appears as if it's coming from the request is coming from the node manager of the host. So that kind of replicates how existing jobs work. But what would be ideal is the complete isolation, where it is from the resource manager or name node's point of view, it is still coming from the node manager. But from the actual containers view, they wouldn't have to think about each other's IP. They can just talk to one another. Yeah, I don't know if that answers your question, but I mean that part clearly needs more work. There's an issue open on Yarn the umbrella issue. And I really encourage you to kind of look at it and contribute to it if you have time.
Hi. How is the resource allocation done for the Docker containers? Is it done the same way through the yarn side and MapReduce side?
Yes. So what the Docker container does is it takes the same CPU and memory settings that are passed down to the node manager as LCE. So for LCE, this will get translated to, I think, only CPU shares on that C group. Whereas with Docker, it will create the C group for that container and use that for the CPU shares and the memory limit, which means that if you're crossing that memory limit, your container will die. And for CPU shares, I think it will just slow down the container. But yeah, it's the same way. It is bound by the CPU and memory. And that is passed from the side configurations. Other questions? No? Okay. If then, thank you very much.